Let's relate these new semantic concepts to some of the old concepts that we encountered in our first lecture. In our first lecture, we talked about jointly possible sentences. And you may recall that sentences are jointly possible if and only if there is a hypothetical scenario in which both of them are true. Now, this concept of joint possibility is closely related but also importantly different from the new concept of joint satisfiability. In particular, jointly possible sentences are jointly satisfiable, but some jointly satisfiable sentences are not jointly possible. So, for example, the two sentences Atari is a cat and Atari is a dog are jointly satisfiable, but they are not jointly possible. Let's see why the two sentences Atari is a cat and Atari is a dog are jointly satisfiable. In order to construct the joint truth table for these two sentences, we need to start with a TFL symbolization. We know that both of these sentences are atomic sentences. And that means that I'm going to represent both of them by means of a capital letter. And I'm here choosing the capital letter A to represent the sentence Atari is a cat, and the capital letter B to represent the sentence Atari is a dog. Now, the joint truth table for two atomic sentences is pretty straightforward. We have 4 rows representing 4 possible valuations. Both sentences could be true. The first sentence could be true and the second false. The first sentence could be false and the second true, or both of them could be false. This is the joint truth table for the two atomic sentences A and B. Now we see in this truth table that it contains a row in which both sentences are evaluated as true, namely the first row in this truth table. And that just means that there is a valuation that makes both of them true, and so that means that they are jointly satisfiable. However, even though the two sentences are jointly satisfiable, they are not jointly possible. And to figure out why, we need to reflect on what exactly this row here represents. So the first row in this truth table represents a situation in which the sentence Atari is a cat is true, and so that means that it represents a situation in which Atari is a cat. And it also represents a situation in which the second sentence, Atari is a dog, is true, and so it represents a situation in which Atari is a dog. But we know that a situation in which Atari is both a cat and a dog is not genuinely possible. Anything that's a cat is not a dog, and anything that's a dog is not a cat. And so even though our truth table contains a row in which both sentences are evaluated as true, this row does not represent a genuinely possible situation. And that's why these two sentences are not jointly possible, even though they are jointly satisfiable. Okay, let's compare necessary equivalence and tautological equivalence. You may recall that in our first lecture together, we discussed necessary equivalence. Two sentences are necessarily equivalent if and only if they have the same truth value in all hypothetical scenarios. In contrast, two sentences are tautologically equivalent if and only if they have the same truth value on every valuation. Now, tautologically equivalent sentences are necessarily equivalent, but some necessarily equivalent sentences are not tautologically equivalent. Let's look at an example to see why that is. If you think about the two sentences, Joe Biden is pictured to the left of Kamala Harris, and Kamala Harris is pictured to the right of Joe Biden, you will notice that they are necessarily equivalent. There's no hypothetical scenario in which only one of them is true and the other one is false. But these two sentences are not tautologically equivalent. To see why, we need again to construct the joint truth table for these two sentences. Now, both of these sentences are atomic sentences. They cannot be decomposed into smaller units that are still available for truth or falsity. And so I'm going to choose two capital letters to represent these two sentences. And I'm choosing the capital letter A to represent the sentence Joe Biden is pictured to the left of Kamala Harris, and the capital letter B to represent the sentence Kamala Harris is pictured to the right of Joe Biden. Now, the joint truth table for these two sentences is familiar. It's TT, TF, FT, and FF. And we see that these two sentences are not tautologically equivalent. In particular, there are two rows in this truth table where they have different truth values. That is the second row here and the third row. Nevertheless, even though these two sentences are not tautologically equivalent, they are still necessarily equivalent. And to see why, we need to reflect on what kind of situation is represented by these two rows in the truth table. Now, the second row represents a situation in which it is true that Joe Biden is pictured to the left of Kamala Harris, and it is false that Kamala Harris is pictured to the right of Joe Biden. But we know that this is not a genuinely possible scenario. And similarly, for the situation represented in the third row of the truth table. The third row of the truth table represents a situation in which Kamala Harris is not pictured to the right of Joe Biden, but Joe Biden is in fact pictured to the left of Kamala Harris. And we know that that's not a genuinely possible scenario. So that means that the second and the third row of the truth table do not represent genuinely possible situations. And that means that even though the two sentences are not tautologically equivalent, they nevertheless are necessarily equivalent. Now let's compare validity and tautological validity. In the first lecture that we had together, we introduced the concept of validity, and we said that an argument is valid if and only if it is impossible for the conclusion to be false when all of the premises are true. Today, we discussed tautological validity, and we said that an argument is tautologically valid if and only if every valuation that makes all premises true is also a valuation that makes the conclusion true. Now, every tautologically valid argument is in fact valid, but there are some valid arguments that are not tautologically valid. Let's look at an example to see why that is. So here's an argument with two premises: Superman flies and Superman is Clark Kent, and the conclusion of the argument is Clark Kent flies. Now it is pretty obvious that this argument is valid. It is impossible for Superman to be flying and for Superman to be Clark Kent and for Clark Kent to not be flying. So in other words, in every hypothetical scenario in which both premises are true, the conclusion must be true. But this argument is not tautologically valid. And we can see that it is not by constructing the joint truth table for the three sentences Superman flies, Superman is Clark Kent, and Clark Kent flies. Now, each of these sentences is an atomic sentence, so we can represent them by means of capital letters. I'm going to represent the sentence Superman flies by the capital letter A, and I'm going to represent the sentence Superman is Clark Kent by means of the capital letter B, and I'm going to represent the sentence Clark Kent flies by means of the capital letter C. Now, the joint truth table for 3 atomic sentences is going to have 8 rows. It's going to look like this. They could either, all 3 sentences could be evaluated as true, or only one of the 3 sentences could be evaluated as true. Or 2 of the sentences could be evaluated as false. Or all 3 could be false. So 8 possible evaluations for these 3 sentences. Now, this argument is not tautologically valid, as you can see in the second line of this, second row of this truth table. So the second row of this truth table shows that there is a valuation on which the sentences A and B are true, but the sentence C is false. And so there is a valuation that makes both premises of this argument true, but renders the conclusion false. So the argument is not tautologically valid. But the argument nevertheless is necessarily valid, or simply valid. And to see why, we need again to reflect on what this second row of the truth table represents. Now, this second row of the truth table represents a situation in which it is true that Superman flies, and it is also true that Superman is Clark Kent, but it is false that Clark Kent flies. Now, just thinking about this situation, it should be clear that this is not genuinely possible. If Superman flies and Superman is Clark Kent, it has to be the case that Clark Kent flies. And so we see that even though the joint truth table for the 3 sentences exhibits a row that evaluates the 2 premises as true and the conclusion is false, this row does not represent a genuinely possible scenario. And that means that the argument is valid even though it is not tautologically valid. Okay, let's sum up. We introduced 3 new concepts: joint satisfiability, tautological equivalence, and tautological validity. And we contrasted these 3 concepts with 3 old concepts that we already heard about a while ago: joint possibility, necessary equivalence, and validity. And we said that jointly possible sentences are jointly satisfiable, but some jointly satisfiable sentences are not jointly possible. Furthermore, tautologically equivalent sentences are necessarily equivalent, but some necessarily equivalent sentences are not tautologically equivalent. And finally, every tautologically valid argument is also valid, but some valid arguments are not tautologically valid. In the next part of this lecture, we are going to acquire some practice and see how we can use truth tables to test sets of sentences for these properties, for joint satisfiability, tautological equivalence, and tautological validity.